Thank you for coming out tonight, and thank you, Daniel, even though you couldn't fly in to spend some time with us tonight, you are able to get to us via Zoom. Daniel has been to this event a few times. He's been consulting here in town, and this is going to be a particularly interesting topic. He has spoken to the PMI Agile Roundtable about what is technical practices coaching. And tonight he's going to talk to us about new learning objectives for Scrum Masters. He has nearly 2 decades as a software developer and been working with Agile teams for 10 years. He's with Agile 42. One of the interesting tidbits about him is that in addition to writing software and coaching teams, he maintains a podcast of short 5-minute topics, and the URL is technicallyagile.com, which I hope is going to be on your final slide, and that those slides can be put in our Slack channel. He is also in our Slack channel if you have questions that don't get answered this evening. So please welcome Daniel.
Hi, guys. So like she said, the focus of this, another coach and I actually put this talk together originally for the Global Scrum Gathering in Minneapolis. And basically what happened in 2017 was they made some changes. You guys might know they made some changes. They put in this A-CSM certification. And one of the things they did was they added some extra learning objectives around technical practices. Now, I don't know, I was going to ask for a show of hands, but I don't know, I only see the center tables. So I don't know how many people are on the other side, so let me do this. I'll ask for a show of hands, and then you can tell me over the microphone roughly what percentage actually have hands up. Sound good?
Sounds good.
Okay, so show of hands, how many people here are working with a team that works in development of software, configuration of software, hardware, or some other technical practice? So I think that's everyone on the screen. Is that pretty much around the room? Okay. So, despite coming from an engineering background, I've coached a lot of teams, and I believe very firmly that you do not have to come from a technical background to be an effective coach or Scrum Master. But it helps, it helps to have this information. It helps to know what's out there and what kind of challenges the team faces. And because of that, I'm kind of happy that the Scrum Alliance put these extra learning objectives in, but it creates a problem. Because if anyone has their CSM or their CSP or progressed on to one of the higher level certifications, it means that now people will expect that you'll have this information and that you have learned it in a class with absolutely no recourse for you to be able to get that information. So that was kind of the problem that we set out to solve, and that's what I want to try to do here tonight. I'm going to throw a ton of info at you. So I have slides. Some of them are a little rich in text. I'm not going to try to read through them and bore you with it. And if it feels like too much info is coming at you, don't worry. The slides will be available. My goal is to kind of give you enough of an overview that you can reference back to this, and it gives you a place to work from. So if you're not familiar with these technical practices, you can look at the slide, remember what we talked about, go Google a video, get a little bit more information, that kind of thing. And through that, you can have all of the information that you need that these learning objectives ask of us in the CSM and A-CSM. Sound good? All right. So let me do a screen share quick and we'll get started. Do you guys see a big blue and yellow slide?
We do.
Yes, we do.
Cool. So, as I said, Daniel Lynn, and quick technical practices refresher. So, let's talk about Agile Manifesto. That's a good place to start with any of this. Where does this come from, right? In our Agile principles, we talk specifically that we want to deliver working product, or in this, it started with software. We want to deliver it frequently. From a couple of weeks to a couple of months with a preference to shorter timescales. I think we can probably all agree that in modern software development, if you're taking 3 or 4 months to complete a piece of software, that's actually pretty long time scale for modern software development. So we're really trying to push towards those weeks, if not days or hours, right? And then the ninth principle is we have continuous attention to technical excellence, and good design enhances agility. So these are the two things that I really kind of want to dig into. This is why we worry about this, even if we're not the ones writing code. And especially that second one, that the attention to technical excellence and good design enhances agility. And why is that? And why it is basically comes down to technical debt, right? So as a team builds up technical debt, that weighs on them, and it slows down their development, and it makes everything that they do more expensive. And kind of the reason behind that, we can visualize it pretty simply here. If we imagine this graph that we have on the left-hand side, if we imagine 4 types of work that we do as a team, we have new features that we develop, we have improvements to existing features, we have bugs that we need to fix, and then just general upkeep and maintenance, right? So most of the work we do as a team can fall into one of these 4 categories. And what's nice when we start off and we don't have a big pile of technical debt is all of our work goes into new features and improvements of existing features. I mean, yeah, a bug comes up now and then, have to do a little bit of maintenance or upkeep, but most of it goes into new and improve. And that means that we have a really high value curve, right? We generate value very, very quickly. But the problem is over time, if we get bogged down into this technical debt, more of our work goes into bugs and maintenance. And that time has to come from somewhere, right? So where does it come from? Comes from building new features and improving existing features, right? And that flattens out our value curve. So just to connect this to something in real life, if you've ever worked with a team where it felt like it took forever to get the smallest feature out, you know, or every time you said, I want to make this change, like, oh man, I got to do 3 weeks of impact analysis and I got to meet with 10 different people. That's technical debt. And it's usually, in my experience, 9 out of 10 times that happens, that's years of technical debt that has gone unaddressed. And so this is where in our Agile Manifesto, in that principle, it says, if I really focus on technical excellence, I focus on good design, and that means paying down and avoiding that technical debt, I will be able to make changes faster, right? So, and by the way, please feel free to, we have time, so feel free to jump in if there are any questions as we go. There are 2 ways that we approach technical debt and dealing with technical debt. The first one we talk about all the time, that's policy, right? So this is my definition of done. This is how do I organize things on a backlog, right? It's not all user stories. It can be other items that need to happen too. How do I have a good architectural runway? This is all policy. And we talk about that plenty in our classes and in our meetups. But what a lot of times we don't talk about is the practices. What are the actual things that we're going to do in the moment to make this work better? And you need both of these. So that's why for the rest of this, we're going to talk about 7 technical practices that are great to start with in a team. And I can say in my experience, the teams that really have control of their technical debt are practicing either most of these practices or evolutions of these practices, right? So I'm going to start really easy. We're going to start with refactoring. I say really easy because this is going to be one of those that people, whenever I talk about refactoring, people go, what's that? And then you tell them and they go, oh, yeah, of course, we do that all the time, right? But if you ever had someone say, oh, don't touch that system, don't look at it, we don't make changes to that, don't touch that database table, it's a mess, no one knows how it works. This is all lack of refactoring. So what we're trying to address here with conscious refactoring is we all make mistakes, right? We all take the option that maybe in hindsight was not the best option, and we accidentally build mistakes into our product, but that doesn't mean we have to leave it there and live with them. Too many times we kind of jam in these little wedges that make it look like our mistake isn't there, right? But it comes back to bite us. So we want to consciously look at this idea of refactoring. Refactoring is it's a change made to the internal structure of software to make it easier to understand or cheaper to modify without changing its observable behavior, right? So when someone says, for example, I'm going to make some changes inside of the data layer, it's going to make later changes easier. That's refactoring, right? You don't necessarily see what's happening on the outside. It's just making things better on the inside. This is something teams do. I would love to say they do it all the time. Unfortunately, if there's any developers in the room, you probably know that oftentimes we don't have a chance to do it. But the reason this is always the top of my list on technical practices is because by calling it out, by naming it, and by consciously talking about it, we make time for it, right? And that's important because, right, change happens, so let's make it easy. Let's put in practices of addressing it regularly. Loosely coupled code, so I'm not going to get into that. If you're a developer, you know what that means. If you're not, don't worry too much about it. But basically, code that's easy to refactor is going to reduce the risk of accidental impacts. And then finally, refactoring is a key part of paying down technical debt. A lot of teams I work with a lot of legacy applications, and they have a lot of technical debt, right? And so they need to use refactoring to kind of dig their way out of that problem. A lot of times it's not a problem they made, but it's one that they're stuck with. Right? So I want to pause there a sec, and kind of if there are questions about refactoring, please bring them up. But I also want to point out that what I want to do with each of these practices, right, is I'm going to step back into my slides a second. I just want to call it out so that so that's really clear. You guys know what to look for as we're going through it. Is I want to share some of these practices with you, a little bit about what's the problem that we're trying to solve, right? What is it? And then some of the key benefits. And the reason I'm doing this, and I'll revisit that conversation about learning objectives later, but this is basically what those learning objectives for the CSM and A-CSM ask of you. You know, can you name the thing? Do you know what it is at an academic level? Do you understand why the team might want to use it? That's what those learning objectives ask of you. So if you come back and you look at these slides later, or as we go through these practices, that's the way I kind of laid it out so that it's packaged in a way that matches those learning objectives for you.
Daniel?
Yes.
For non-technical Scrum Masters,
yes.
Could you talk a little bit about what this looks like on a team? Are they redesigning? Are they recoding? What else might they call it other than refactoring, so that Scrum Masters know when it's happening, when it's not happening, and what they're trying to make space for?
Oh, that's an awesome question. Thank you. So I think they usually call it like refactoring, or it's a re-something almost all the time, right? Re-architecting, redesigning, improving or solidifying. The kind of key sign to look for is if the result of refactoring is always that it makes your life easier or cheaper later on, and it's pretty much impossible to see the result. So this is some of those classic backlog items where someone says, I can't demo it, but it's really important and it'll really help later on, right? There's nothing to see, but if I don't do this, it's going to cause all kinds of problems for us. That's almost certainly a sign of refactoring. And the next practice is actually test-driven development. I do want to say that refactoring doesn't need to stand on its own. Wrapping refactoring into development is actually often a better way to do it. But sometimes you didn't, right? Sometimes you forgot to, or you were under a time crunch and you didn't, and then you just need to make time to refactor after. But yeah, if it's one of those, I can't see it, but it is going to improve the quality or longevity or performance of the product, that's almost certainly refactoring. Does that answer the question okay?
I think so, unless somebody else wants more information.
Okay. So, second practice we'll talk about is something called test-driven development. It's one of the most common and probably one of the most well-known ones out there. It is exactly what it sounds like, right? So test-driven development is a practice oriented around this cycle. It's called the red-green refactor cycle. And how it works is I write a test. Now, if a test is red, anyone in the room guess what that means? Sorry, I'm making you walk around with a mic, aren't I?
Somebody had a great answer here.
It means you haven't written it yet.
Close.
I turned it on.
You've written a test, but you haven't coded anything, so obviously it failed.
Spot on, right? So especially in it means it failed. Red means it failed, but in test-driven development, of course it failed. We've only written a test, right? So then I move, in my next step, I write just enough code to turn it green. No more, no less, right? And so green obviously means it passes. Now, I mentioned refactoring before, and that refactoring doesn't have to be a separate activity. In test-driven development, they explicitly call out that every time I move to green, before I write my next test, I take time and decide whether or not I need to refactor. So the idea is I go from it doesn't do a thing to it does a thing simply to it does a thing elegantly, we'll say. And I build this is a cycle in which I write all of my code, right? Everything I want it to do. I want this to throw an error if I get this type of data, okay? Write a test to look that it throws that error. Write just enough code so that it does it and that test passes, no more. And then refactor, make any code changes you need to make it maintainable and sustainable application, right? So why do we do this practice? One, it lets us tackle work little by little. This is one of those wonderful practices that has a lot of benefits, and this slide doesn't even really do it justice. But I tackle work little by little. These cycles often resolve in minutes. On the long side, maybe it takes upwards of an hour to get through one of these cycles. It probably never takes longer than that unless you're really stuck on a problem. Right? So these are really short, taking really small chunks out of work. And every time, I'm going to jump ahead to the third bullet, every time you complete one of these cycles, you have working software. Recall from, again, back to Agile Manifesto, working software is our primary measure of progress. Every time I complete one of these cycles, I have a releasable working software. And then I also have, I can build really complex interactions and applications through these small, simple behaviors. And I have less of this problem of, oh, it's just this big, hairy mess that no one knows how it works, right? Because I deliberately took it step by step through it. And it results in very clean, very streamlined code with a very broad, a very good understanding of how it functions. As a nice side effect, it creates a large set of automated test cases that you can run as many times as you want, right? This is at the unit test level, but you can run these as many times as you want, and you have fairly full test coverage out of it. One of the downsides to test-driven development is something that a guy named Dan North came up with, and this led him to something called behavior-driven development. Now, the name being similar is no accident. He looked at test-driven development, and if I think of an application, I kind of have layers of an application here, right? At the bottom, I've just got this little bit of code logic, and then I have pieces of code talk to each other and integrate it, and then I string a couple of those together and I have some business functionality, and then I get to the top and I have interaction and my user can start engaging in my application, right? TDD only really looks at those bottom two. And what Dan North realized was I can use TDD to write an application that works exactly how I told it to and solves none of the user's needs. All right. So he saw test-driven development as fantastic, but ultimately insufficient by itself to get the job done. And so enter behavior-driven development. Right. This takes the exact same approach. You still do, if anyone was here a number of months ago, someone actually did a presentation on behavior-driven development, got into a lot more detail than I'm getting into here. But this is exact same thing. I write a test that doesn't work because I ain't written any code yet. I write just enough code to complete, and then I take time to refactor. I use the exact same cycle, but these tests are at a higher level. They're at my that interaction level, that business functionality level. And so I want to give you guys a chance to engage with this a bit to kind of see what this looks like. I have on the screen a picture of, basic web payment processing system, right? Is that clear up on the monitors? Okay. So I'm going to put some information in there. And other than that is not a valid zip code. Can anyone tell me what the problem I'm going to have here is?
The date's expired.
Oh, that's one I completely missed. Awesome. Perfect. That was not the one I was thinking of. That's great. So the other one that I was thinking of was it's not a valid credit card number, right? Mathematically, it's not a valid credit card number. Either of those perfectly good examples. What I want to ask you guys to do, let's just take, 45 seconds, turn to the person next to you and describe in plain English what you would expect to happen next from the application. How should the application handle this? Just 45 seconds, turn to the person next to you, describe it in plain English.
I love your hitchhiker's guide document.
All right. So the idea behind behavior-driven development, one of the thoughts on it is that where the developer is obviously the best person to express what code should do, in the spirit of Agile, the best person to express what the application should do, what are those user needs, are those stakeholders or users, or in the case where you might have a product owner who's speaking on their behalf, that's the person who should do it. And that person doesn't necessarily know how to program and shouldn't need to know how to program for this practice to be effective. And so part of this practice is defining tests in plain language. And what they did, there's this syntax, it's called Gherkin, because programmers are weird, right? The thing that ties into the compiler is called cucumber and gherkin's a pickle. So I don't know what to tell you. Programmers are weird. So there's a syntax called Gherkin. If you've ever seen anything that says, given something, when something, then something, that's Gherkin syntax. The idea behind here is it's plain English. You can give this to anyone on the street and read it. I say English, it can be any language, it doesn't matter. And anyone can write it. I can ask a user to write a new test case. I can ask my product owner to write a new test case. I can ask anyone to, right? And then what happens is the developers, when you want to automate this test, the developers will basically write some code in the tool that says, hey, when I see this particular pattern of words, this is how I run that automation on the background, right? And then over time, it's able to recognize more and more and more patterns of words until you get to the point where I can just write new versions of tests and it's going to pick up on patterns, and they're either fully automated already as I write them or very close to it, and it requires very little work on the part of developers. So this is this idea in behavior-driven development is it takes the idea of TDD and extends it further up the application stack. So I start engaging my users and my stakeholders in the exact same process, right? And when I look at the key benefits, you'll notice a lot of the same things show up, right? I'm working software is my primary measure of progress, right? Because I go red, green, refactor. My development is still focused and targeted through these test cases, and that results in cleaner, more elegant code. I have a large set of automated test cases as a handy side effect. But again, to come back to these top benefits, I'm pulling in stakeholders, I'm pulling in users, my product owner, to collaborate with the development team, right? So that we both have the same idea in our head before we even start writing code. And it's nice that it's easy to add new cases and examples as we discover them, right? So I kind of hit a couple of them. I'll pause before going on to the next one.
Daniel, are they actually testing on BDD as well as TDD and calling BDD a technical practice?
Just so I'm clear on the question, is who testing?
The Scrum Alliance for the new CSMs?
Yeah, so I'll show you the wording, and but behavior-driven development is certainly a technical practice. They actually, the learning objectives are really open-ended. They ask you to list a certain number of them. And the highest number that they list in any of the learning objectives is 5. So by 7, we kind of overshoot a little bit. And they give examples, but they don't say, well, it has to be these. It's probably a bit broader of an answer than you specifically asked for. But so I have working code. I have a set of test cases. But what's the next problem we run into? Anyone ever here, it works on my machine, right? Or that definitely used to work when I wrote it. This is something that we look to continuous integration and delivery to help us solve, right? And that sounds really fancy, and they make all kinds of really expensive tools, so it's really helpful for the industry to make it sound really fancy, but it's not. When a programmer checks out the code from SVN or Git or whatever source control you happen to use, and they hit the button on the compiler that says build, and then they hit the button that says run tests, that's all this is. Basically what happens in continuous integration is there's some automated box somewhere, right? Maybe it's a virtual machine. Maybe it's, I've worked with teams where it was literally like, someone got a new machine, and so their old laptop became the CI server, and it just sat next to everyone else in the team over in the corner of the office, right? So it doesn't have to be particularly sophisticated, and all it does is whenever someone makes a change to the application, it tries to build it. And if it fails, it tells the team, hey, I couldn't build this, right? When I pulled it all together, it wouldn't build anymore. And then it runs, if it builds, it runs all the tests. And if those tests fails, it sends a message to the team and says, hey guys, whatever you just changed broke a bunch of tests. You should fix that before you start building new functionality, right? So that's all a CI server really is it is a machine that when the application changes, it tries to build it and run the tests. Now, there are some good practices around it, right? The closer I can get that machine to be like production, the more valid those tests are, the more valid that validation is. But ultimately, it's just a machine that builds the application. And so a lot of teams spend, frankly, an incredible amount of time. I've seen teams spend sprints trying to decide their strategy for continuous integration, and it's just way overthinking the problem, right? Get a box, have it build, have it build your code, and there you go. You've got basic rudimentary CI. Continuous delivery is just taking that step further, and the idea there is once it's built, why not deploy it, right? Now the question obviously is to where. Most teams work in many different environments. They probably have 4 or 5 environments from their machine out to production. And, the answer to that really depends on you, your team, your company. Some people can go to an integration environment. Some people can go all the way out into like a staging or production-like environment, which is great. That gives you a lot of validation. I know of one. I personally know of one company that I've interacted with that every time they check in code, if it passes all the tests, it deploys to production. Now, they have a lot of other things put into place. They have something called feature flags, which means that most users can't see those code changes that go to production right away, but they can validate them in production, make sure they work properly, and then they flip a Boolean and true false statement in a database, and now suddenly users can see it, right? So that's the whole CI/CD really isn't that amazing or complex. I think people overcomplicate it to sell tools sometimes. It can be complex if your environment's complex, but then if your environment's complex, you probably know how to get your way around it. So the benefits that it delivers are huge, though. You get really fast feedback on integration errors, right? I can't even tell you how many teams I know that wait to integrate because they're worried it's going to be scary, and then it's a self-fulfilling prophecy. 3 months down the line, they pull all their code together and nothing works right anymore. So let's find out fast and fix the problem when the problems are small. It creates a common build platform. It gets rid of that "it worked on my machine" problem. It creates a platform for running those automated tests and static code analysis, which we'll chat about in a minute. And I think this is the most important, at least when I was professionally writing software, when we get good at the things we do often. And deployments are scary. I've worked plenty of places where deployment meant I didn't plan to sleep for 2 days. Deployments are scary because we avoid them and we never get good at them. And by doing this, if we do continuous deployment, we'll iron out the kinks. They'll stop being scary if we do it all the time. And certainly from a development standpoint, that was probably the biggest payoff to me. So I think took us through 5, right? There's 2 more, and these are 2 that for some reason get the most pushback that I see. And the first one's pair programming. And I'm going to try to do that show of hands thing again. You guys are on a much smaller window for me now, so it's hard for me to see. But show of hands, anyone here hit the mob programming meetup that you guys do? Looks like a few. So I'll reference that in just a minute. But you guys saw who had their hands up? Go talk to them if you want to know more about this, right? Pair programming is really simple. It's 2 people coding together. That's it. 2 people on one machine. And the idea here is that 2 brains are better than 1, right? When we develop applications, especially complex applications, what's difficult, it's not typing code. That's not the bottleneck. It's solving problems. It's figuring out why that server is doing that weird thing it's doing, right? And having 2 people look at a problem helps you through those snags much faster and helps you catch errors before they go out into production much better than the benefit that you get out of simply having people type more efficiently, right? Which is really if you ever have this argument of, but if I have 2 people coding, I can type more code in faster. Yes, you can. Studies have been done on this. It shows that to write a known piece of code it takes about 120% of the time, right? So there's an extra 20% if everyone knows how to write that piece of code already, if it's like a college code exercise. That's not a big gain. And when we look at these things where people spend weeks banging their head against a wall trying to solve problems, those weeks become days or hours. And that's a big payoff. That's a lot bigger payoff than that 20%. So the other payoff that we see, this is an exercise one of our other coaches did. He asked a team to write down on sticky notes how they felt when they programmed. What emotions did they feel? What does it feel like, right? We see there's some stuff fun, at ease, some of the pen I can't read, right? But then there's a lot of negative stuff, pressure, blocked, filler, endless, right? Huge section of negative. And then they went through and they did a pair programming exercise, and they asked, how did that feel, right? And you can see there's the two sides switch. The number of negative emotions attached to it's much lower, and the positive section is huge in comparison. So they've almost flopped each other. You know, there's notions of it feels faster, it feels fun, it feels I can't read it on my screen now. I have this other one, but all these positive emotions. And yes, you do have people that feel like they're slower, right? The most senior people in the team are going to feel as though they're slowed down because they might be teaching junior people as they're going, right? But that's not necessarily bad in the long run, because you're going to get more people at a higher level in the long run when you work this way. And then, of course, there's mob programming. So what I was going to try to do here, let's see, video doesn't work so well. I usually play a video of mob programming. But what I'm going to try to do is, instead of playing the video, I'll just kind of click through a couple points. This is a picture of, there's a number of teams actually practicing mob programming in this video. And notice, let me move to a point where they're all, so here's the team, right? They actually have two keyboards here. We have a couple of people sitting around, same thing over here with this team, right? Just watching them on these screens. So again, their brains are engaged. It doesn't matter how many people are typing. That's not the important thing when we develop software. The important thing is engaging brains and solving problems, right? And this carries on. You'll notice there's a clock up here. This is 9 a.m. And it just kind of carries on, right? This is their day. That looked like a rough one. Oh, I can't get back to it. His head was in his hands. Right, but this takes the same concept a step further. And if this seems like a problem that your teams are facing, that they're stuck trying to solve problems, and and individuals get stuck for long periods of time, man, use the fact that you guys have a mob programming meetup in your area. That's so awesome. I'd love to have one of those in Denver. Go out to it. It's a great, easy way to engage with the idea and try it out. I know, I'm going to say for myself, I loved pair programming. We did a little bit of mob programming, and I'm going to be realistic here and pragmatic. I didn't do it dogmatically. I didn't pair every single line of code that I wrote. There were some things that were kind of data entry, and I just sat down alone and did it. But anytime we had to solve a problem, we'd get together with a pair or a triad, and it always got solved so much faster. Can't recommend that one enough. It does feel like it's inefficient, though, and so it gets a lot of pushback, right, wrong, or otherwise. So key benefits of this. More brains on the problem leads to faster problem solving, fewer silly human errors. You get huge amounts of knowledge sharing on the team, right? If you've ever run into that's so-and-so's code, I don't know how that works, that completely goes away, right? And 4 eyes see better than 2, right? You're less likely to just make human mistakes if another person's looking over your shoulder, right? Or more to the point, you're not less likely, it's more likely that they'll catch it. Spikes. Is it safe to assume everyone's at least heard this word? Yeah, so this is one of those commonly misused words that I ever see, right? I've heard more definitions for spikes than I can count. And they really solve this problem. When you say, I don't even know where to start, that's the time for a spike. And I have a bit of an example that we can use that doesn't require any programming knowledge. So imagine I have an application and it's called Face Space. I'm sure you can imagine what it does. Helps people connect to other people. And imagine you're part of the development team. And I want Face Space to do a couple of things for me. I want them to show me people who I went to high school with. Sound easy enough? Show me where they live now. Show me their occupation. Show me if they're married and have kids. And finally, I wanted to control my hot tub. Which of these is different from the others? The occupation one, right?
The last one.
So I want to point out that it's not different really from a programming standpoint because of the fact that it doesn't have to do with connecting people. It's different because when I look at this, I don't know where to start. I haven't the slightest, like the rest of these are all I connect to a database, I do some string matching, who cares, right? But this, I don't know how the heck hot tubs work. Can I actually do that? Is that a real thing that happens? How do I even know if they have a hot tub, right? Like, I don't even know where to begin with this. And as soon as you say, I don't even know where to start, that's the place for a spike. So rather than try to define what a spike is, a spike has three major characteristics. A spike tackles a specific aspect of a problem with the intent to drive out unknowns or risks. A spike is time boxed. For people who use story points, best practice is don't use story points. It's a time box, right? It's I'm going to spend X number of hours. And that doesn't mean it's the maximum number of hours that I can possibly spend working on this. It means that after this many hours, I'm going to bring it back to the team. If I've solved it, if I haven't solved it, whatever I've learned, I'm going to bring it back to the team. So we usually want this number pretty small, right? Let's say I spend 4 hours and I come back to the team and I said, so it turns out you can control hot tubs, but only certain ones that are enabled with Bluetooth and only if you have this app on your phone. That's awesome information to have, right? That's a good 4 hours worth of work. But I don't, these problems are inherently open-ended. So I put these time boxes on to keep them from getting away from me. And then finally, prototypes and demonstrable learning is preferable to research, reading, and conversation. So to use the same example, it is more valuable for me to say, hey, look, I wrote this horrible, script put together with bubblegum and duct tape, but it turns on my hot tub, than it is for me to say, I found a manual that says I can turn on my hot tub, right? Sometimes the manual is all you got. Sometimes all you can do is research, read about it, have conversations with people. This really comes into play when we talk about architecture. So when someone says, I want to design a database table, or I want to see if information is available in a data source, I would rather write a script that pulls that information and shows me the information. I have proven that the information is available and this is what it looks like. That is more valuable than to scroll through databases and just try to research whether or not I can get that information and then put it down in a SharePoint site, right? Sometimes all I can do is research, but if I have the option, I would prefer to do prototypes and demonstrable learning. Right? So the key benefits of spikes: drive out risk by trying and observing. We improve user story estimation, right? And that really comes down to it makes more of the estimate about the actual effort and complexity and less of the estimate about risk and unknowns. And finally, it solves risk avoidance in teams. I run into this a lot. I don't know where to start is very close to I'm not going to start, right? That's a very easy jump to make. I don't know where to start, and so I don't. This gives me an option. When I say I don't know where to start, we can say, what's the most important problem to solve, and how long would you like to spend trying to learn more about it, right? So it's really, really valuable in that. Definitely want to pause there because this is probably the one that gets the most, like when I'm coaching and people talk about, hey, what are your list of problems? What's a spike and how am I supposed to use it comes up probably the most. So I want to pause there and see if there are any questions on that.
I've got one.
Oh, sure. Yeah.
At what point do you know when you should can something in a spike?
Wait, just so I'm clear, what do you mean by can?
Well, you're researching something and you realize this thing is a bigger hill than it's worth climbing.
I think in my experience doing development, as soon as you feel like that might be the case, I would bring it up to the team and the product owner. As soon as that came into my mind, I would say something. And I mean, because you can always, they could always say, let's put a little bit more into it. Let's put another 2 hours and see if it clears up, right? But as soon as I think it might not be worth the trouble, I would bring that learning up and why I think that up to the team and the product owner.
Okay.
Does that answer
I've been
the
there
question?
more than once. Yeah, I've been there a lot of times, and it leads to a lot of headaches and a lot of cost overruns, depending on who the product owner is and who the client is.
Oh,
and,
yeah, absolutely.
how you deal with it. So.
Yeah, if we've become attached to that feature, hearing that it's not worth doing is a really rough conversation to have. That a spike does not fix.
What does it look like on sprint backlog? Is it a special category? It's not a story, it's not a task, it's a spike?
So I only see that distinction, that question come up if you're using a tool. And, right, because if we're using like sticky notes, who cares? It's a sticky note. What I usually do, if I'm using something like Jira that can do custom objects, sometimes I'll go as far as to create an object just so that's very clear that this is something different. But what I personally also always do is somewhere in it, I put in what that time box is. So depending on the tool, that might be in like the hours field, I might put in what that time box is, or I might even just put like 4 hours in brackets at the end of the description or the name of the backlog item. So it probably depends on the tool. Like I said, in something like Jira where I can make a custom one, I usually do. If I'm in something like, I don't think version 1 does custom types yet. And then I would just put it in like a backlog item and put like the word spike in parentheses in front of it or something. But it is a distinctly different type of backlog item than the user story.
And what happens if you run out of time and it hasn't been solved yet?
Well, so that's the time box is just the maximum amount of time before you bring it back to the team. So like when you bring it back to the team, a lot of things can happen. You can either decide it's not worth spending more time on. You can decide it's solved enough that you can move forward with, like a user story that relates to it. You could decide that you have more time you can spend. Like, hey, I think if we spend another 4 hours, we'll break through this. And I don't think that spending those extra 4 hours will put the sprint goal at risk. And then the team might go, okay, great, let's spend another 4 hours. So there are a lot of options there. The time box is just to say, at this point, I come back to the team and we decide together what's the right next move. The other thing we're going to talk about was static code analysis, and I'll give this a short treatment. and hopefully it'll make sense. And the example we always use, I'm going to rush through it. I'm going to give you 3 quick examples in English. First sentence, what's wrong with the first sentence? Sid can play tennis as good as his brother. Sorry, I'm forgetting we're walking around with a microphone. I'll tell you what, for time, first sentence, right, it's as well as. So it's a grammatical problem. Second sentence, when you become a parent, you will think different about children. Differently. So adverb versus adjective. But the third sentence, this is the type of errant pedantry up with which I will not put, is a horrible, horrible sentence that is perfectly grammatically correct. And the reason that we use these examples is if I translate this to programming, the compiler will catch the first 2. Those are syntax errors that a compiler can see and the program won't build. But the third one is not a syntax error. It has all the grammatical rules correct. So just like if I'm writing code, I can write code that's horrible code that compiles fine, right? And so static code analysis, there are these tools that go through and look through your code and find these problems, right? And they find these dangerous patterns before they become bugs. They find deprecated code. And most tools are configurable to put in extra rules based on Teams coding standards. So specifically, this is a thing, you run it against your application, and it gives you these reports about where these potential problems lie, right? And it just does it a lot faster than a person can. If you have thousands and thousands of lines of code, reading through it yourself is tough. Sorry to give that last one a super short treatment. So these are 7 practices, right? They're really short amount of time dedicated to them. But what I wanted to do was give you something to latch onto so that you can go back and look at these slides. If I look at the learning objectives, right? CSM asks, define technical debt and explain the impact of accumulating technical debt, right? List at least 5 practices that help Scrum teams deliver a high quality product increment, and list 3 ways technical practices may impact the development team's ability to deliver, right? So we tried to hit that with this first conversation about how technical debt slows you down and these key benefits around the different practices. A-CSM, the first 2 are actually really similar. They ask you to think a little deeper about the practices, but again, it's 5 and 3, same basic ideas, but it adds another completely different thing. And that is, how do these engineering practices help you at scale, right? And so what I tried to do on the slides is put these places where something adds extra benefit when you're talking about multiple teams coming in addition to the benefit that it adds with a single team. So I will post these on Slack. I know they said they'll put it up on the Meetup site as well. And certainly I'm on Slack. Welcome to email me if there are more questions about this. But hopefully this gives you kind of a rundown of information as well as from the slides. You have things if you went, hey, that BDD sounds right for my team. Let's dig into it a little bit more. You can go up onto YouTube, look up tutorials on it, read blogs about it, that sort of thing, right? And that's it for me. Any other questions that have come up?
I had a question. So why would we all want to work on the same module of software in relation to, from an investor standpoint, how do you justify, or how do you compare one senior programmer who knows how to do it himself to a pair of entry-level software developers going at it, A, from a financial side, B, from a communication side throughout the organization? Then also, why wouldn't we all work on an individual model and then rotate through it? Does that make sense? Why would you all work on the same little piece if by same effect, everybody would get to work on the full stack or whatnot? If that makes sense.
Yeah, so what I can speak anecdotally and say that the research that has been done, which depending on how much you're looking for, you may feel is insufficient fairly, but the research that has been done matches my experience, and that is that the teams that focus end up getting more stuff done faster than teams who don't. There are exceptions, right? But those exceptions usually prove the rule. So in really highly specialized environments, so like if I look at Boston Dynamics, who's building cutting edge robots, that's going to be an exception, right? They're going to have really specialized people focus on very specialized aspect of that robot. Self-driving cars is another one of those that often is an exception to the rule. You have very specialized skill sets focused on incredibly bleeding edge technology. But in your average, like data-driven applications and processing of data through mainframes and that kind of thing, the benefits that people get off of putting many minds on a problem consistently get more gains than the efficiencies that you get about many people working on many things. That's what I've seen. And I think that speaks to the financial aspect of it. From an agile standpoint, I would also point out that by splitting people, you drive up your work in progress. And, you know, Lean has tons to say on why you should keep a low work in progress, right? So it allows you to start things and finish things, and it tightens up the cycle that you return to a usable, stable product that you can release and put out in front of people. That also assumes that you want to do frequent releases, right? But there's a whole work in progress argument to be made for it as well.
So, in relation to like a sales team, I wouldn't want my whole sales team to show up to a sales call, but I would want to meet up with them if I found that I had discrepancies with the client and go pick their brain particularly. But it feels like everybody would show up and everybody be like, oh yeah, I know how to solve this for you. No.
Absolutely. So I think that this gets into when I said when I did this, I used it pragmatically. If I'm doing data entry, I gain no benefit, right? There are certain tasks that I'm unlikely to create human errors on, and I'm not solving a problem, right? And those I don't see the same benefits. And so when I did it, I will say that when it was time to solve a problem, we always worked in groups. When it was time to do something monotonous, we split up the work. But I found that was probably 80-20 or 90-10 with us working in groups to 80 or 90%. But yes, I mean, you know your environment. So I think your team should be making the call about when they're going to get more benefit by more brains on a problem, or when they're going to get more benefit by dividing up what it really boils down to kind of manual labor.
So we are several minutes over time.
Oh, sorry.
No, that's okay. And we do want to let our host go home. There are the resources I know you can share in Slack with regard to scholarly papers on mob programming, and a new book out there on that, lots of research on pairing. We can share that in Slack. And thanks everyone for coming. Please let's thank Daniel, and remember that we can go down the street and meet at Kells and talk the rest of the night if you want.
So jealous. Drink one for me. Thanks, guys.